Last lesson of our unit 4.8, we are going to be applying our trig functions into actual scenarios, real world scenarios that we might actually use. But first things first, let's say we are given a triangle. This is probably good to know for our SATs. So, and we are given two thetas. When they say the thetas are like that, that means these two angles are the same. They are the same measure. And we want to find B. We want to know what theta is. We want to find B is given some answers, right? So let's say we are given this theta as 28 degrees. And they say B is 19. And we want to find out the altitude of a triangle. So for those you that might forget, an altitude is a line that draws a perpendicular to B, and we want to find that height. Well, that's not so bad. So if I cut one of those triangles in half, right, then this is 28 and not 19, but half of 19, which is 9.5. So this is 9.5. And now I just need to find this particular height right there. This up and down height here. I'm going to put this in blue. So let's use our thinking cap. We have here, this is an opposite, right? And we have an adjacent. So we can use tangent. So our tangent of 28 must equal whatever our height is. I'll call this an H for a height. Height divided by 9.5. Well, then our height must be 9.5 times the tangent of 28 degrees. Make sure you have your calculator on degrees and no longer radian. So tangent of 28 times 9.5. It gives me around, they say round to 2 decimal places, so 5.05 will be our answer here. 5.05 is our altitude. Okay, let's do another example. A popular example that I see a lot is there's the sun, and the sun is behind a building, like so. And so the building casts a shadow, like so. And let's say this is 25 degrees. This angle is 25 degrees. The building is 100 feet tall. How long is this shadow? Well, this is our thetas right here. We got our opposite. We want to find this length here. So we have our opposite. This is our adjacent. I'm going to use tangent again. So tangent of 25 must equal 100 divided by whatever, I'm going to call that x, the length. Solve for x. X equals 100 divided by tangent of 25. Punch that in, and I get 214. We want this in 2 decimal places, 0.45 feet. And that's our answer for that. Let's do a bit of a complex one. Let's say I have a plane in the air. Not the best drawer of planes, but plane is flying up in the air. It's looking at us. And assume the buildings, not the buildings, but the cities are within, the towns are on the same sea level. So assume sea level, or the same elevation. So here's one town. And here's another town. And the plane from one town to the other town, and from the height. So it is 10 kilometers up high. And from where it's flying up high, its degree from we'll call this town A to town B. Town A is 53 degrees. And then from town B is 28 degrees. And they want us to find the distance between town A and town B. So there's multiple ways of going about this, but I'm going to break this down into two triangles. I'm going to break it down to this triangle here. This is going to be my first triangle, and my second triangle there, and they kind of overlap. And then I'm going to subtract their two lengths, and that should give me the distance between the two. So first things first, I need some other degrees, right? This is assuming this is 90 degrees right here, because it's straight up from the ground. This here, this first one, I'll call this one theta. Theta is it's gonna be 90 minus 53. So this is 37. This is 37. The theta that I'm gonna use for this first triangle here. So this will be 37. This is 10. I want to use tangent then. So tangent of x, I'll call this x, tangent of 37 must equal x over 10. So for x equals 10 tangent of 37 gives me, I'm going to round this to 7.54, 2 decimal places. Let's do the next triangle, the purple one. The purple one, I want this entire angle, right? So then that is 90 minus 28. That gives me 62. So the purple one is 62. I'm going to call this y, and this is 10. So then my tangent of 62 must equal y over 10. So for y equals 10 tangent of 62 gives me 18.81, around there. Subtract the 2, so y minus x should give me my actual distance. So 18.81 minus 7.54, that gives me around 11.27, and they wanted to round it to 1 decimal place, so it's actually 11.3 kilometers apart. This was in kilometers. Yeah, the first unit was in kilometers. Let's do one more problem that's a little bit more complex here. Let's say I am at a parade, and in the example they gave us a witch float, and I'm like, you know what, I don't really want to do a witch. I want Pikachu. So not the best drawer, but Pikachu float it is. He has his little right here. There. Let me decorate him some more. He's got some black lines. Make him happy. Okay, it's good enough. And let's imagine here now I'm holding Pikachu from the top, right there. And I'm over here holding Pikachu at 3 feet above the ground. And Pikachu has a certain height. I don't know what it is, but he has a height. I'll call this H over here. Mimic that, that's the height. And from there to me, from wherever that peak of that to me is 100 feet. So I know this is 3 feet. This is 3. There's a lot going on here, right? There's a lot going on in this picture. We'll call this length here L. We don't know what theta is. What is theta? What is that particular angle right there? First things first, what is L? How can I find L? Well, if I drew this triangle out and I just drew it just as a plain triangle, I have 100 feet here. I have H for part of it, and then I have the rest of it. Oh, let's say from here, from the H, from the here to here, this is actually 20 feet. So this is 20 feet. So this is H, this side is H plus 20. I need to find out, I just got to use Pythagorean theorem. So here, 100 squared plus H plus 20 squared must equal L squared. I can multiply all that out to try to find my L. But, oh, wait a moment, back it up. This is 20, the whole thing is 20 feet. That means this particular triangle stops at 20 minus 3. So it's not 20. It's 20 minus 3, which is 17. So 17. 20 minus 3, yeah. So this would be 17. H plus 17. Okay. So then L must equal the square root of all that. I'm going to combine this in this particular instance. Normally I don't, but this is H squared 17 times 2, that gives me 34. 34H. 17 squared gives me 289. So this is, and 100 squared gives me 10,000. So here this is H squared plus 34H plus 10,289. And that would be my theta now. Let's do theta. Theta, we have, so here's theta. My theta is going to be, well, I have my adjacent. I know what L is. My theta could be, I could use the cosine. So it's the inverse cosine of 100 divided by L that I can do. And so now, let's solve for H. Okay, so let's solve for H to see what that has to be in order for all these things to work out. Let's say they give us now theta is 30 degrees. So let's say theta is 30. So if theta equals 30, so we do 30 equals the inverse cosine of 100 divided by L. So then we can take the cosine, right? So cosine of 30 must equal 100 divided by L on both sides. And then L must equal 100 divided by cosine of 30. So then that's divided by cosine of 30. That gives me 115.47 and some change, but I'll leave it like that. Now I can plug this back in. I don't really want to work with this equation. I'd rather work with this equation right here. So now I'm going to plug it into that one. So then 1,000 equals H plus 17 squared must equal 115.47 squared. Square that. 115.47 squared gives me 13333. That's a 332. This is a plus. This is 10,000. Apologize for that. So now H plus 17 squared, 10,000. Subtract 10,000 to both sides. H plus 17 squared gives me 3,000. 333.32. Square root. H plus 17 equals 57.73. Subtract 17. H should equal 40.70, around ish, 74, maybe 73, 74 for our height.